Welcome to our channel. Today, we're diving into a massive botanical mystery that's honestly been driving growers crazy for decades. We are going to look at why maxing out your nutrient feed, specifically your phosphates, might actually be actively destroying your crop's potency.
Let's just jump right in. You know the drill. You're doing everything by the book, right? You're meticulously measuring, pouring serious money into top-tier nutrients, and pushing those plants to the absolute limit just to get those massive, dense harvests we all see in the magazines. But here's the catch. A ton of dedicated cultivators are running into this really frustrating hidden reality. We're talking unexplained stunted yields, diminished flower quality, and locked-out nutrients that just don't make any sense. It's super common, and it perfectly highlights this crazy paradox we're exploring today. So why exactly is feeding your plants more costing you potency?
Well, to wrap our heads around this puzzle, we really need to map out how a plant actually uses phosphorus across its entire life cycle. Think of it like a journey. Back in the seedling phase, phosphorus is basically the lead architect for building those early roots. Then, during the vegetative stage, that expanding root system acts like a giant battery, soaking up and storing massive amounts of this crucial element for later. But then we hit the flowering stage. This is where plant scientists talk about something called intense sink strength. There is this huge, sudden shift in demand. In late flower, a staggering 80% of all the phosphorus the plant absorbed gets routed straight to the unfertilized inflorescences, the buds. Now, because that late-stage demand is so incredibly high, a lot of us are absolutely terrified of a true phosphorus deficiency. And honestly, the anatomy of a genuine deficiency is super specific. It's always going to show up on the older, lower foliage first. You'll spot these unusually dark green, almost bluish leaves, and that's usually paired with deep purple or red stems. If you don't catch it, you start seeing sunken olive green spots, and those dark purplish leaves start curling, eventually turning into these ugly bronze necrotic splotches. Basically, the plant's overall growth just hits a solid brick wall. But here is the absolutely crucial takeaway. Seeing those terrifying symptoms doesn't necessarily mean your soil or substrate is actually empty of phosphorus. A lot of times, it's just an environmental trigger causing the headache. For example, if your soil temperatures drop below 60 degrees Fahrenheit, which is right around 15 degrees Celsius, phosphorus gets virtually immobilized. The plant just can't touch it. It's the same deal with an incorrect root pH. If your pH is off, it can completely block uptake, acting like a locked vault door right between the root hairs and all those nutrients you just fed them. So what happens next? Terrified of underfeeding and totally misinterpreting these signs, a lot of growers just start dumping more and more phosphorus into the substrate, and boom, that leads us straight into the toxicity trap. This is where things get so incredibly deceptive. You see, an excess of phosphorus rarely looks like a classic overdose. Instead, it acts like a silent killer, locking out other vital micronutrients. Your plant is literally swimming in phosphorus, but suddenly it's showing signs of an iron deficiency, with those brand new leaves turning a really unhealthy bright yellow. Or maybe you'll see severe leaf edge burn, or even experience a complete lockout of calcium and magnesium. The crazy part is that excess phosphorus is perfectly masquerading as entirely different nutrient problems. And that brings us to this fascinating scientific concept known as a luxury consumption. This is what happens when a plant absorbs nutrients way beyond what it actually needs to survive, without giving you any agronomic benefit whatsoever. Essentially, the plant turns into a compulsive hoarder. It aggressively pulls up available phosphorus and packs it deep inside its cellular tissues. But here's the kicker. That hoarding doesn't translate into more overall biomass. The plant isn't getting any bigger, it's not getting any healthier, it's literally just getting stuffed with excess minerals. This biological hoarding mechanism is exactly why the cultivation industry fell for a massive, deeply ingrained myth for decades. The historical standard, the one written into almost every old-school grower's handbook, demanded over 200 milligrams per liter of continuous phosphorus. And the flawed logic kind of made sense at the time. Hey, if the plant can take it up and store it, it absolutely must require those massive levels to give us a maximum harvest, right? Well, not exactly. Recent agronomic studies have just dropped an absolute bombshell that completely shatters this long-held myth. Heavy phosphorus feeding actually triggers what researchers are now calling a yield dilution effect. When you push those massive phosphorus levels, the concentrations of THCA and CBDA inside the dried flower tissue can actually decrease by up to 25%. Think about that. You're actively diluting your own harvest's potency simply by overfeeding. Please like and subscribe. It really helps our channel a lot. And the problem doesn't stop at potency, because there's also this massive amount of waste happening behind the scenes. When researchers tested different phosphorus inputs to see how the plants physically responded, the results were incredibly telling. Tripling the input from a modest 25 milligrams per liter up to 75 milligrams per liter yielded absolutely zero extra flower biomass. Literally zero. But it did create a massive 12-fold increase in wasted leachate runoff. So you're pouring expensive fertilizers right down the drain for zero agronomic benefit, and as we just learned, you're potentially wrecking your active chemical compounds at the same time. Let's talk about the next harsh reality of overfeeding. All that wasted phosphorus doesn't just safely disappear into thin air. It flushes right out of your substrate, and if you're a commercial grower, it creates a massive localized liability for your farm. When excess agricultural phosphorus leaves your root zone, it starts pooling directly on your immediate property. This severe runoff is literally draining your financial resources, but it's also putting you at a huge risk for violating local agricultural compliance ordinances. Especially if you're an outdoor cultivator, managing this localized runoff is absolutely critical if you want to maintain your farm's soil integrity. To capture these highly mobile, wasted nutrients before they become a massive regulatory headache, you really need to be deliberately planting vegetative buffer strips. Ideally, we're talking at least 35 feet, or about 10.6 meters, wide. These strips act like a natural, giant sponge on your property. They keep your expensive inputs localized and stop your farm from becoming an environmental target. Okay, so we've identified the core problem. We've totally debunked that old historical luxury consumption myth, and we've seen the severe localized damage it can cause. Now it's time to actually fix it. Let's pivot away from the myths and the damage and finally reveal the exact science-backed protocols you need for optimal, high-potency growth. Here is the heavily guarded, scientifically optimal phosphorus concentration target. You absolutely do not need 200. You don't even need half of that. You only need a fraction, precisely 30 to 60 milligrams per liter. For American growers, that translates directly to 30 to 60 parts per million. Peer-reviewed research shows that a continuous supply kept strictly in this exact range is entirely sufficient to achieve your maximum yield. And the best part? It does it without triggering luxury consumption, without wasting your entire budget on runoff, and critically, without causing that dreaded yield dilution effect that destroys your crop's chemical potency. But look, just providing the right amount in your mixing tank is really only half the battle. The plant actually has to be able to access it down at the root zone. To keep this precisely measured phosphorus continuously bioavailable, your pH has to be perfectly dialed in. For you traditional soil cultivators, your optimal range is a pH of 6.2 to 7.0. Now, if you're running a hydroponic or soilless setup, you're going to need to run slightly more acidic, targeting a very strict range between 5.5 and 6.2. Staying strictly inside these parameters is what ensures maximum uptake efficiency, keeping you completely clear of both nutrient lockout and that compulsive luxury consumption. To bring all this together into a practical, everyday strategy, leading agronomists rely on what's called the 4R Nutrient Stewardship Protocol. Let's quickly break this down. Step 1 is the right source, meaning use highly soluble synthetic nutrients for your closed-loop hydrosystems, or rely on slow-release organic sources like bone meal if you're building a living soil. Step 2 is the right rate. This means relying on tissue and runoff testing to stay firmly in that 30 to 60 part per million sweet spot, completely avoiding any luxury uptake. Step 3 is the right time. You want to time your feeds so you never apply phosphates to already saturated, wet or frozen soil where it's just going to instantly wash away. And finally, step 4 is the right place. Applying your fertilizers directly into the root zone, sometimes called subsurface banding, which maximizes root interception and guarantees zero waste. When you finally understand the actual biological demands of the plant, you stop feeding into the old myths, and you can actually start cultivating for maximum undiluted potency. Think about it. Are you ready to cut your nutrient costs in half while actively boosting your harvest strength? Thanks for watching. This content does not constitute medical advice, legal advice, or recommendations for the use, self-treatment, or consumption of any substance.